Good morning, good afternoon, and good evening, wherever you are joining us for Digital Twins in Oil and Gas. My name is Nicole Bamford, and I'm the moderator for today's session. On behalf of Leslie, Angelique, Quinn, and I, we thank you for joining us this afternoon. This presentation, Fabrication, the Missing Piece of Your Digital Twin, will be given by Ray Simonson, CEO at Glove Systems, and Mahdi Sharif, SVP of Product Engineering. And their presentation promises to be well worth a listen. Before we get started, here are some quick administrative points. During the webinar, if you have any questions for the presenters about anything that they've raised during the webinar, please submit them in the Q&A box on your screen, and these will be answered at the Q&A session following the presentation. Likewise, for any technical issues, please write them into the Q&A section and we'll get to them right away. The widgets on your screen can be resized and dragged around. We encourage you to visit the Resource Center on your screen for additional content and resources we and our sponsors have provided for you. So make sure you're sitting comfortably, and now I'll hand it over to Ray so we can begin.
Thank you, Nicole, and welcome everyone wherever you are in the world. My name is Ray Simonson, as you heard. I'm the CEO of Glove Systems. Glove Systems is a University of Waterloo spin-out. What we are doing is commercializing 30 person years of research conducted in the Civil Engineering Department at Waterloo under the directions of Dr. Carl Haas, who is, by the way, a co-founder. And in that work, we have we're bringing to the market a ton of research on metrology, comparative measurement, fabrication work processes, and adding to that, we are bringing a ton of knowledge in web-based, cloud-based applications. Mahdi Sharif, who is one of the co-founders, has spent 5 years working with Aecon in their fabrication shops, understanding the work processes that go on in fabrication. And Rob Payne, our CTO, has about 30 years of experience building complex cloud-based business-to-business web applications. So at the end of it, we're experts in metrology, in work processes, and in cloud-based applications. We're going to quickly go through a definition of a digital twin. We're going to tell you what we think is missing from digital twins. We're going to suggest why fabrication's not part of the digital twin right now. We're going to try and define some values to project owners if they do include fabrication and construction in the digital twin process. And then we're going to take you through what Glove Systems does and conclude with a question and answer session. Digital twin has been around for a while. I believe originally it started as the 3D model and often the 3D process model of a facility. And over time, it has gotten a lot more complex, and it now is really a digital replication of an operating asset, or at least that's the goal. The important thing now is to understand that the digital twin is no longer just an engineering concept. It is now something that lives across the entire life cycle of the infrastructure. This definition is from a book, Infrastructure Computer Vision, published by Ioannis Brilakis and Dr. Carl Haas, who, as we mentioned, is one of the founders of Glove Systems. This is a picture, a little simplified, of the life cycle of a plant, starting from design, going through fabrication, installation, and ending up in operations and maintenance. And I realize we're missing a few other important parts in there, but these are the parts that we're talking about in regards to digital twin. And the definition would say the digital twin starts in design and grows all the way across to operations and maintenance and gets used over there. We think there's a missing piece of that twin. And if you look at this, this is our definition of what's going on now. You start in engineering, you do a bunch of work and create a digital twin. and then somehow you move it over to operations and maintenance. And we would contend that you end up with a less than complete digital twin because you're missing fabrication and installation and construction data. So what elements are missing? Well, in the fabrication process, of course, lots of activities go on that are going to be, and the capture of these will be useful in your digital twin in operations and maintenance. So what we're saying is accurate and complete measurement of as-built assemblies should be in there, and other data, pictures, documents, certificates can all be associated with your digital twin in this step of the fabrication process. Why isn't fabrication a part of a digital twin right now? If you look to the picture on the right, you will see some people measuring, in this case, a feeder tube for a nuclear reactor. The tools they're using haven't changed much since we built the pyramids. So there's a tape measure is made out of plastic now, but it's a tape measure. There's a square, there's a level, and probably a plumb bob. Those tools have been used in the industry for years. People are used to them, but the problem with them is they don't transfer to anything digital. And the other problem with them, of course, is they're not really repeatable accurately. Of course, there are tools to measure things like this that are digital. And if you look at the picture in the center with the gray picture with the white spots in it, that's showing a laser tracker setup, which can do a very good job of measuring to a high degree of accuracy and giving that back to you in a digital form. However, the problem with those is that the tools to do that are hard to use. They're time consuming. And again, there's no real easy way to take that data and bring it back to your digital twin. These are, again, great tools, but designed for engineers, not for craft workers in your fab shop. We would argue that if you're a fabricator, you should want to be using a digital twin in your fabrication processes. We've shown, and I will get to this later, that if you have a 3D model that you can share with your craft workers, you're going to improve quality, lower costs, reduce mistakes, and generally improve your processes in fabrication. We'd also suggest that nowadays, when there's shortage of skilled people, good tools are a value in attracting people to come and work in your industry. If you're a plant owner, you should want your fabricator to be using a digital twin, because if they do so, you will get a probably lower cost, higher value product. And if we do this properly, and all your fabricators are doing this, you will have less rework on your job site, things will fit together faster, and you will have a tool that you can use for training your own operations and maintenance staff. We conducted, in order to prove this, we conducted a study in which we took 40 engineers in training and 21 experienced pipe fitters and had them go through a process of broke them up into two groups and had them go through a process of building a pipe assembly, pipe spool, the old way and the new way. And what the results show, and by the way, there's a URL at the bottom of the page which will take you to the actual study. Simplifying it, basically we found that when people were using 3D models, also digital twin, the average time to understand and interpret the design of what was to be built was less than half. Also, because mistakes do happen, what we did find that if you were using traditional tools, it took 3 minutes to figure it out. And if you're using glove tools, which includes the digital twin, you're going to find your mistakes and fix them in half the time. So there's a substantial improvement in productivity when you use more modern tools, and the digital twin is one of those. So at this point, we'd like to ask you a question. And am I in charge of this, Nicole, or are you in charge of this?
You're in charge, Ray.
Okay. So please, we're going to give you some time to answer these questions. Are you using digital twins now in your design phase? Please click yes, no, and we've offered that it's complicated in case it is. All right, so this is interesting. So we see about 24% of you are using digital twins now in design. I actually thought it would be higher than that in the oil and gas plant space because the big players, Intergraph, Bentley, Aviva, Dassault would argue that they are digital twins. The no number is a little disappointing because we should be doing this. And it's complicated. Anybody who said it's complicated, feel free to send us a message saying why you think it's complicated. We understand, but we'd like to get more information. So the next question, are you using a digital twin now in your plant operations? And I'll give you 40 seconds. I'm presuming as we watch this, Nicole, we will see answers come in, or should I go back?
You need to stay on the answer or on the question screen, Ray.
All right. All right, ladies and gentlemen, again, are you using digital twin in your plant operations? Yes, no, or it's complicated? Would expect the numbers here to be much lower. All right, let's see what happened. So it looks like 15% of you are using digital twins in plant operations, and congratulations to you. I presume it's well worth it. 72% are not, and we again have 12%. It's complicated. So it's interesting that it's about, well, my memory's good here, it's about half of you who use it in design or using it in operations. But the whole purpose of a digital twin is to be useful in plant operations and maintenance. And so it appears there is some work to do here. So last question of this section, if you're not currently using a digital twin, are you planning to use a digital twin? And we're talking in either operations or in design. Right. So the good news is significant majority of you are planning to use that. And that's great news for the industry and for those of us who sell software related to digital twins. All right, now we're going to talk about what Glove Systems does and how it can help in building a useful digital twin. We take a four-step approach, and the first thing we do is bring into our software not only the cut sheets, but the 3D model or the digital twin. We find that by doing this and making this easily available to the craft workers on the plant floor through generally touchscreen computers, that people can now look at that 3D model, rotate it, measure stuff on it, and very much more quickly understand what they're trying to build. The second step is to collect the 3D as-built data, and we do that using a variety of sophisticated 3D laser scanners, and we set up on the floor and we shoot pictures of that, and we bring that into our software. So after you've loaded the digital twin or the 3D model, and you've loaded using the software the point cloud of the as-built assembly, we will compare and measure. And Nicole, let's see the video. Oh, here we go.
In this session, we will be investigating the utility of Glove Systems platform for inspection of large and complicated modules. In this page, as you can see, we have a 3D model of a nuclear module that was about to be built. You can see this is a complicated and large module. One end is 15 meters and the other face is about 7 meters. Within the module, there are many pipes with different orientations and angles, and also pumps and valves. Glove Systems was asked to come in and laser scan the module after it was built to point out to any deviations or, because of the complexity of the assembly, any items that might have been forgotten to be installed or was in the process of installing. On the right, you can see the 3D scan point cloud of the module after it was acquired. You could see the pump, you could see the pipes, and the structure. On the left, you can see the 3D point cloud of the model. This is how we expect the assembly to be. On this page, we have selected 3 corresponding points between the scan and the model to overlay the two on top of each other to see any possible deviations. Let's go onto the analysis page and look at the results. After coming to the analysis page, this is the first feedback that we will see. We would see the model overlaid on the point cloud. The overlay itself, before generating the heat map, could provide some valuable information, including, for example, I could see that this pipe on the bottom here has not been yet installed. I could also see that I have a significant deviation for this pipe along this run over here. A couple of the things that we could see is some of the items like the fences at the bottom have not yet been installed. However, they were deemed that they were not critical. We could see that this pump, that is an extension here, does not exist in the model. So we were able to follow up on that with the fabricator. We could also see that this ladder it is not part of the model and should be detached, and the only reason that it's installed is to allow the fabricator to build the second level of this module. Let's generate the heat map and see what kind of feedback we would get. So here's the heat map of the overlay. As you can see, the heat map can quickly identify the fact that we have a significant deviation here. We could also very quickly identify that this pipe has not yet been installed, and we could see that this ladder and the attachments of it are all not part of the model and need to be removed. With the heat map and the link, you could also see how far off you are on the pipe. So let's use this feature and see how it performs. So if I click here, I could see that I'm off of about 6 centimeters. The total time for this inspection was less than 3 hours, which is significantly faster than the alternative approaches. In addition to fast inspection time, providing the 3D data resulted in quick identification of errors and saved time in communicating these errors across different stakeholders.
Thank you, Marty. And so that was a reasonably easy to use, simple process for identifying issues in your fabrication. Now, of course, that's what you see on the in the fab shop while you're using this. And what we want to do now is share the results of this with the project owner or the EPC who is running the project. So let's go see that video. So what we're seeing here is what you would see if you were the project owner and your fabricator had shipped you this different module, of course. This is an assembly for an offshore platform. And shipped it to you so that you could look at it. And what's happening in here is the owner or project manager, in this case, is examining the assembly to compare and determine if things are up to spec. All right. And I will say that when we started this business, the idea of sharing this stuff on the cloud was viewed primarily as a cost saving, avoid the expense of sending people to travel. That advantage has now become huge as COVID has established that people just don't want to travel anymore. So in conclusion, Glove Systems envisions a future where project people and construction people and operations people are using fabrication data to improve the entire process, not only of building facilities, but of adding value to the digital twin for continued use in plant and operations. And we do this by adding better tools to the fabrication process and making all the data available in the cloud. One of the huge benefits to this, of course, is now you don't have to travel to the job site to determine if the assemblies that you're having built are dimensionally accurate. So this is where Glove Twin comes in. We have built an assembly, what we call a as-built assembly, that you can add to your digital twin and enhance the value of your digital twin throughout the life cycle of your plant. All right. So we have a couple more questions, and then we'll get into the Q&A session. So the first question, as a plant owner, EPC, project manager, do you give your fabricators a 3D model to do their work with? Answers are yes, no. If you are a fabricator, please answer, I am a fabricator and I don't get it, or I am a fabricator and I do get it. And of course, not sure. So we'll give you a few minutes to answer this. Sorry, a few seconds. 40 to be exact. All right, this is interesting. 40% of the project people say that they give their fabricators a 3D model. And yet only 8% of fabricators, the fabricator don't get a 3D model. Okay, so interesting. I think this is a problem in the industry, and we'd like to pursue this in the question and answer period. But clearly, I would say the digital twin is not involved in the fabrication process, and therefore you are missing critical data in your digital twin when you get it into operations and maintenance. So I want to thank you again. I believe Nicole will be opening the question and answer session. And after that, we'd encourage you to come and look at our website, arrange a demo, and talk to us about our free trial for people. So in response to COVID-19, we're offering a free trial to qualified fabricators and project owners. So Nicole, can we get the first question?
Of course, Ray. So the first question is from Ben, and Ben asks, inspection time of 3 hours, but how long to process the data obtained during the inspection?
You want to handle that, Marty?
Sure, yes. So the 3 hour includes the actual acquisition time. So we spend a lot of time on the floor to make automations and streamline the data transfer between this laser scanner to your workstation and then providing the final analysis. So when we say the 3 hours would from the time that you set up your laser scanner, scan, compare, and then see the result and then potentially share that.
Thanks, Marty.
Perfect. All right. Our next question is from Rajiv, who asks, DT's adoption in plant is dependent upon people who have not much use to digital methodologies. What is your position on this and how to tackle it?
Methodologies. So the answer to that is, again, when we started doing this, our focus was, how could we make something that is so simple to use that everybody could use this? So in my times of spending time on the fab floor, I remember that this fabrication shop that we worked with had a $200,000 laser tracker that no one knew how to use, and they ended up using their tape measures, and they stumbled their way through the fabrication of that project. So what we said at the beginning was, we're going to make something that it's a tool for the fab worker. It's not going to be a tool for the engineer. It's not going to be a tool for your metrologist. So the answer to your question is, you're right. People are not typically well-versed in metrology. And what we've done is we've created very simple and easy to use process and interface so that everybody could leverage.
And I can say that took about 5 years of research to try and get what is essentially a bunch of complicated stuff built into very easy to use software. And those of you who do software realize that easy to use is actually hard to build. So again, great team. We built a great application, and we've had it used by people with no experience in metrology or software.
Great, thank you. The next question is, in your experience, is it the fabricator or owner of the asset who invests in 3D scanners?
That's it depends question. So certainly the use case and the value to a fabrication shop of investing in it is reduction in rework. It's the ability to train new people quickly and make them productive. It generally gives you much faster QA, QC, as you heard Madi explain how long it took to measure that nuclear assembly. And of course, nowadays, as a fabricator, if you have this kind of technology, you don't need to have the owner's metrology team walking into your shop to measure stuff. So there's a good case for fabrication companies buying their own. However, if you're a project manager, plant owner, and you want to make sure that your fabricators are using the stuff, you can do one of two things. You can require them to buy this kind of technology, or you can provide it to them. And it really is probably based on your contracting strategy and how you run your project. We think there's good value in the plant, the project engineer having the technology and pushing it out to their fabricators, because at the end of the day, you will be able to give all this as-built data to the owner in the handover process.
Perfect. The next question is, for subsea manifold, how does the actual subsea temperature variation is simulated before commissioning?
So we're probably going to have to chat a bit more about this question to understand it better. But I think the initial reaction is, so at the end of the day, you've got tolerances, and you've got a 3D design. So what we would do is we would get the as-built status, and then can compare with the 3D model, and then can tell you whether or not you're within tolerance, and if you're off, how far off you are. The simulation of temperature variation, I think, would be reflected into the design and the determination of the tolerance values of the manifold. But we're probably going to have to need more. We need to understand more about this question. So let's take this offline.
Okay, great. What happens if on a project we don't have a 3D model?
Okay, Marty?
Sure. So we're working on a range of quality control tools that would add value without having a 3D model. So we want to become this quality control platform. So it would include pictures, videos. We're working on looking at termination points. So for example, if you want to know on your as-built, what is the distance from the center of your flange to the center of your other flange, you don't need to have the 3D model to know that. To know that. Or if you want to make any type of measurement that's shareable with others, you could just do those with the raw scan. So the answer to that question is, if you don't have a 3D model, we still can add value for quality control processes.
Great, thank you. Next question is, if we were to implement your software, how would that work?
Well, essentially, you would contact us. We would reach an agreement. As I said, we have during the COVID times, a 3-month free trial. And so what happens is, assuming you have a scanner, we would ship you some software. We would tell you what kind of hardware to install it on. And you would take our training course and you would be set up. Now, at the same time, we're setting up an instance or a tenant in our cloud so that everything you do will be stored on the internet and backed up forever and shareable. So it's a pretty quick process. We think that you could be up and running in half a day, and that's how it would work.
Great. Next question is, how much the digital model can be made nearest to the original one if some of critical data / parameters are not available, because many critical data are untraceable in brown plants after many years of operation?
So great question. And we had to deal with somewhat similar problem at our nuclear first. So essentially, you've got design data that does not necessarily accurately reflect your site condition. So the question is, well, what do we do about that? So there are two answers to that. With respect to quality control right now, at the end of the day, your quality control personnel is responsible to make sure that the as-built complies with the design. So the first step is, well, if your design is wrong, for sure your built assembly is going to be wrong. And then the second part of that is, well, how do we fix that problem? So we're working on a new product that would essentially grab the site condition and it would grab your as-built condition, and then marrying them up, you could pre-visualize their fit up, and you could do that. And in the interim, what you need to do is there are a lot of companies nowadays that could go on site, build a 3D model for you that's representative of your site condition, and then you can take that to create new design data. But we can probably chat more about that too.
Okay. Now, the next question is, don't legacy design software already offer this functionality of comparing fabricated item to design models? And if so, what added value does Glove Systems offer?
Good question. What we offer is essentially understanding the fabrication work process. So you're right. The ability to compare a point cloud to a model exists in a range of software. However, you don't see many laser scanners implemented in the fabrication shops. The reason for that is the operation of taking a laser scanner, use it, grab the data, put it in an SD card, process the scan, clip it, import it into a comparison platform, and then report the answer. That's almost a day job of someone dedicated in doing this. So what we've done is we've done a lot of automation throughout this life cycle to make the process as seamless as possible and as fast as possible. So from the time that you grab your scanner, you could have a reasonable time between to see the analysis result. So that's kind of what our value proposition is to do it as easy as possible, as fast as possible on the fabrication floor.
Perfect. Thanks, Madi. Next question is, how much latency for the twin to sync up to the data?
It depends on your connection. Sorry, Ray, connection, but our data isn't heavy data, so we're talking about 100 megabytes of data, and the time to upload that is kind of what you're looking at. Go ahead, Ray.
Yeah, I was going to say it's kind of a function of your internet speed. Our application, as we said, is cloud-based, so we're constantly talking to the cloud version, and the software that's running in the fab shop is talking to the cloud. Now, I will say there will be times when you will be using the software and you don't have a connection to the cloud, in which case the system will still work. We will capture all the data, and it will get synced with the cloud the next time you connect to the internet.
Great. Thank you, Ray. Next question, how does this Glove Fit One help in interface management?
So interface management is one of the most critical activities on major capital projects, and there are software solutions out there that are trying to address this. We understand from talking to our friends at BECT that one of the biggest contributors to project delays and cost overruns on large capital projects is dimensional mistakes. So if you are using a system like ours, all your fabricated modules and assemblies, if they fit the model, if they fit the design, then in theory, they will fit and interface together properly when they show up on the job site. I will admit that right now, that is assuming that both modules are using the latest version of the design, which occasionally goes wrong. As Madi said, we're working on actually identifying connection points so that in the future you would be able to take two modules and compare them in terms of fit up. But that's a future product.
Great. Thank you, Ray. Next question is, at this time, very few EPCs share the 3D models with their fabricators. Do you know why this is?
I wish we did. I believe in some cases it's because the EPCs consider those design models their intellectual property and aren't willing to share it. I think in some cases the fabricators haven't asked for it. Probably in some cases the fabricators don't have technology to look at 3D models properly. And I think Madi can add to this, but sometimes breaking the 3D model up at the EPC level into the work packages is probably some cases considered too much work for the EPC. If there are any EPCs on this call, please throw something in and tell us if we're right or wrong. And Madi, I know you've got some thoughts on the process of trying to build the cut sheets from the model.
Yeah, I mean, so what happens is basically you get this work package, which is your isometric drawing, but then to break that isometric to cut sheets and then getting the 3D models, you need to have advanced work packaging software, which some do and some don't. So that's another aspect that creates complexity.
Great, thank you. Last question. Can we talk to your customers to validate your gains?
The answer, of course, is yes. I would caution that, our customers are busy doing their own job, and so we don't want to bother them with hundreds of questions. But anybody who is legitimately interested and as part of their process wants to talk to any of our customers, happy to comply.
Great. All right, well, thank you very much, Ray and Madi, for that interesting and informative webinar. For those in the audience, if you want to listen again, this webinar will be available on demand shortly. Finally, thank you to you, wherever you are, for taking the time to listen in, and remember to check out more of our upcoming and on-demand webinars at oilandgasiq.com. Have a great afternoon.